something else. We can think of developing in these technologies. We may think of developing in other technologies. We may customize some existing software which are already being available over there. So a lot of solution strategies can be chalk out during that phase, and then for every alternatives, they can think of like how much manpower is necessary. Okay, and then accordingly how what will be the cost of development, what will be the overall development time. Okay, overall possible development time. See, the development time, no one can tell exactly how much time it will going to take it at the early stage. But thing here is that there are different experienced peoples are there in the industry, and based on that industry, based on their experience, they may give a guess, or based on their past experience with that similar type of project, they can able to estimate what are the possible time it will going to take. And the time is also depend on the resources mean mainly the manpower. Okay, the manpower, the more number of manpower if you put it, then the overall development time will going to be reduced, but at the same time it will going to increase the cost. What is the level of manpower that you're going to put it? That means how many experienced developer you're going to put it, how many freshers you're going to put it. So lot of things that need to be taken care while finding out the solutions for different strategies, alternative solutions. Okay. Now again after that they perform the cost benefit analysis key. If we go by this, I mean this, and that will going to be the cost, and how much is the budget I mean what is called, the client can have. Accordingly only they can able to jump into that particular project. Okay. Then they basically reject these things because it's very high cost. It may happen to high cost, then manpower constraint. Okay, and obviously if they are not expertise in a particular feature of that particular software that clients wants to develop. Say I have given an example of say scanning, automatic scanning of the mark sheet. So if that particular company do not having similar kind of experience or technical expertise, it's a similar kind of properties, possibly they may say no, we are not interested in that because we cannot do that. So I mean cost, manpower limitations, technical reasons. There may be so many reasons through which I mean the company can reject that particular project, and it is happening almost every day. And this is the thing that is actually going on in software company. Now next is basically, if let us assume your if some way you have done your feasibility study and you have accepted that thing, and then they what they do, they now start showing mm, interest into that particular project. So what will happen? So that is that it moves to the requirement analysis and specification, and it's very difficult phase. Okay, it's very difficult phase because it is something that helps in converting the dreams or plans which are there in the customers or clients mind into reality. Okay, so that's very challenging because clients always are not very well familiar with the nitty-gritty of softwares, possibly who knows. And then they may try to I mean the developers or not developer, the analysts. Okay, the ones they go over there to the site that is the client's location, they conduct a series of meetings. Okay, just only one target: what is there in the customer's mind. Okay, what is there in the customer's mind, they want to read that thing very carefully. So it's very difficult. If it is a known kind of system, it's very easy. Say examination department, examination system. These are something easy because these systems are very well practiced system for long time. So the software company as well as the client, that is our examination department, say, they are somewhat familiar with those systems, so it is easy to communicate. But there are some situations where it's very difficult that what is the customer's manual system and what they would like to develop for that. So that is very tricky kind of a situations. So that basically the requirement analysis is just to understand what is exact requirements of the customer. So then it need to be documented properly, because documentation, as I mentioned, is very important, and that is the main target of this requirement analysis and specification phase is just to understand what exactly customer is looking for, and then document them properly. Okay, so that if you can divide these things into two phases, one is that's why it's named called requirement analysis and specification. There are two things. One is called requirement gathering and analysis, another is specification. Gathering and analysis means try to read the mind of the customer and do certain analysis how what it is, and then once it has been captured from the customer, and you need to be specified in a proper form, that we call it as requirement specification. And the requirement specification is the legal document. Okay, it will going to be ultimately it will going to be legal document. um, so legal document, why it is legal document? Because the- both the parties need to be signed legally in that specification, which means that yes, customer and client will say fine, software company have rightly taken up their requirement. Okay, and they have to develop these things, and company from side point of view, I mean, they cannot deviate from that whatever requirement they have agreed upon. So that's why the requirement specification is a document that both the parties will going to be agreed upon into that. They cannot violate from that. Okay, so now see, let's what happening in case of requirement gathering or requirement analysis. So it's try to collect different types of basically they try to the company tries to understand the manual system, the existing system customer wants to develop into a I mean, software. Say, let us assume the earlier the railway reservation system was completely manual. Okay, manual ticketing system and everything. It was manual. Now there are lot of issues. Which are there in the manual system. Now, say let us assume railway have planned to develop a good software that will help in their reservation system. Now, since Indian Railway is so complex kind of system, it's not very easy to understand the whole system by some of the developers. So naturally, what will happen? A team of analysts they come sit with the higher authorities in the railways. Let us assume, and then if needed, they will also go to the lower level officers also to try. Just their target is just to understand what that manual system is, what the existing system is. Okay, so accordingly they collect all the related data from the customer, and then they do lot of study or analysis with the collected data, so that they can understand what actually the customer wants. Okay, and possibly they can go by some kind of initial drawing, okay, diagram. Okay, how what will going to happen over there. Okay, and then if there is any inconsistencies or incompleteness, because once they analyze these things, and whatever they understand, they try to make it a documentation, and then they show it to the clients, and then client can correct if any error or in understanding any of the particular requirement, then that can be corrected over there. Okay, so that is the role of client. When once they show it, you see this is our initial understanding about that's what you want, and whether to see whether this is the thing that you are looking for. So if client says yes, this is the thing that exactly we are looking for, then it's fine, no issue. But otherwise, the client can say no, there must be something which is missing, which is missed by you. So you please incorporate these things, or you change this particular phase. So these inconsistencies or incompleteness in the requirement can be rectified. I mean, by this series of meetings and all. And as far as possible, they normally remove these, inconsistencies from that requirement analysis. Okay. Now, how basically it is happening? They basically need to do the gathering of the requirement. Okay, the requirement gathering. Okay, so you see here there are a lot of things that can be steps that can be taken up. Okay, um, you can take help of use case diagram. You will see later on use case diagram. If time permits, I will show you use case diagram. So then that means it's a kind of a diagram of the whole system that they can show very broader way. Who are the, in case of use case diagram, what it is showing, that who are the users of that system and what are the functionalities which are there. Okay, say for an examination department, who are the users? The control of examination, the teacher, the staff, the students. Okay, so they are the users. And what are the functionalities? That marks calculation, bigger one I'm talking about, the marks calculations, result publications. Okay, before examinations, internal marks registrations. So lot of activities or tasks which are there in examination system. So use case diagram based on also it basically shows the in broader way how what are who are the users of that system and what are the functions, or who will going to use which functions. Okay, because of say marks entry system, there will be no access to the student, but student can only see the view the results. So that means function specific, who are the users and everything that can be shown through a diagram, what we call it as a use case diagram. Now, in addition to that, there may be a small group they may interact. If it is very large organizations, they meet with the some groups. Okay, say for example in our university, the university is planning to develop the entire university management system, or UMS. Okay, or management system. So in that case, so there are different modules which are there for that. That means the different I mean, part of that software. It's not only one software. Say my finance related activities, say admission related activities, say administration related activities, say teachers related activities, say student related activities. So there are different people, subset of people. They work for a particular type of task. So the company people can divide their team, and then they go by different subset of people in that organization. Say if two or three people, they may come and meet with the finance team, finance people in our university, so that they can discuss how the finance team is actually working, what is their way of working, what are the things that need to be there in the software. So everything that they have to take out through series of meeting. Then some people may go and meet with the dean student welfare. How will basically handling admission process, how you are handling the students related data and everything, what you want to be there in the software. So these things need to be captured by team. So focus group, you can say that thing normally called focus group. And then you can have a kind of a brainstorming meeting that can happen, and then there may be interviews that can happen with the client side people. Okay, and then you can do a kind of a survey that can happen. So and then one thing that I'll come later on, that is called prototyping. This is another model. Okay, this is another model, prototyping. So that also can be done, and through that they some way able to capture the requirement of the client. So so as I've mentioned, basically it happening through series of meetings, interviews, discussions. Okay, and time to time taking, and then they try to grab all the requirements from the user. So since it's a manual system, since it's a very complex system, so it's naturally, if it is a new kind of system the company is facing. So even if it is already there, some similar one, that is also the style of working in an organization is completely different from some other organization. So you cannot have a universal software. Yes, of course, there are few things that can be done universally. Okay, but organization to organizations, their working procedure is different. So that's why their requirements will be different. So initial stage for a series of meetings, there may be lot of contradictions can happen. There may be lot of ambiguities that may crop up over there while gathering those requirements. Okay. Um, and since they do not have a system, say let us assume they are not using any software before it, so naturally they do not have an idea how the system will going to be look like. So that's why since with the lack of any such kind of practical experience of handling similar situation in the form of a software, clients also make the developer highly confused. Okay, not developer, analyst, they're highly confused with their lot of bombarding requirement or need, that we want this one, that we want that. Possibly there, I mean, it's the role of the analyst to narrow down these things, their requirement, and then confined into this. He said, this is C, this is the core part. We're going to develop such a kind of a module feature for that. And if necessary, you can do with the help of this. So for that, you don't need require a very big software for that. Say if someone wants, I need a kind of a what is called documentation for my finance activities. So for that, you have to give me a kind of a space where I can type it. So then developers may, or the analyst may say, "Okay, why you are going for that? It may increase the cost. Instead of doing that, why don't you write it in an MS Word?" And then you can upload that particular MS Word file into that system. So then it is a very easy solutions. So that way, lot of contradictions may happen, ambiguities may happen among I mean, client and the developers or the companies. And then gradually, after series of meeting, they try to nullify all those contradiction or inconsistencies between the two parties. Okay. Now after that, it goes for the requirement analysis step. Okay. And then as I mentioned, the analyst, not one people, there may be a team of people with the stakeholders, mean the clients. Okay, with the clients, mm, they basically mm, they try to understand by the analyst, and then analyst what they will do, they will prepare a kind of a document, what we called it as SRS document, software requirement specification document. Okay, that is their job. Analyst job is just to capture the requirements of the client well, after series of meetings and all, after resolving different ambiguities. Okay, and then finally they're going to produce a kind of a standard document, what we called it as SRS. Now, this SRS is the building block of the entire software. Building block means if there is any flaws in this SRS, then the whole software is going to be ended up with that fault. Okay. Now that's why the system analysts are very, I mean, very senior people, very highly experienced people, high paid uh, job, because the entire thing depends on the SRS. Okay, because rest of the phases will not never going to interact with the client. Okay, they will just follow the SRS document, and SRS documents are not like a simple document. SRS document actually basically a conversion of client's requirement into a standard form. Okay, standard form, so that that can easily be implementable. Okay, that easily implementable. Not I'm talking about the code, but it is easily implementable after a proper designing. Okay, because this is just a requirement. What is their requirement? What the client actually wants. Okay, so basically the engineers who are doing, as I mentioned, that requirement analysis specifications are called the analysts. Now after that, what happens? This once your SRS is ready, then the design team will take up that matter now. Next, this is the next phase, and then they design the architecture of the whole software. Okay, the architecture of the whole software that can be implementable by the help of any programming language. Okay, so designer or architects are basically playing that role, that they convert the SRS document into a design document, and then that is their freedom. What design methodology they will going to do, how the software codes will going to be developed, how what are the functions will going to be there over there, or how one function is dependent on the other functions. So all those architecture of the software in terms of different functions, input, output, everything. It's the role of the designer to design. It may be they may adopt a function oriented design. They may go for object oriented design. So it's completely up to the design team. It's completely up to the company's policies and everything. Accordingly, they may plan for such kind of designing. Okay, and which language to be adopted accordingly. Whether there will be changes in the what is called the design and all everything. The designer will going to design based on that SRS document. Okay, so during design phase, what happens? The software architecture is derived from the, as I mentioned, that SRS document. So either it go for the traditional functional approaches. Normally nowadays it's almost nil, because most of the project, almost all projects are object-oriented approach, because almost all languages are somewhat object-oriented or object-based coding language. So the designs are also, they follow these things. The use case diagram or whatever diagram that I'm talking about, we'll see later on. Then they normally based on object oriented approach only. So that's why nowadays the everything is now shifted towards object oriented software design. So there are two type of activities that happen. One is structured analysis. First they do it, and then it go for the structured design. So we'll study these things during the design when we'll study in details the design. So what we call it structured analysis and design, with the help of different diagrams. With the different diagrams, it will show what are the major functions which are there in that software, and what are their relationship among them, so that will can be done in through structured analysis and design. So say for example, a kind of a hierarchical diagram I am showing it over there. It is to be done by the designer itself. So first what they do, they basically do identify all the functions which are to be performed. And of course these design team, they never go back to the client. They only refer to the SRS. Okay, they only refer to the SRS. So they identify based on what is the customer's requirement which are mentioned in that SRS. Okay, because SRS actually brought down the overall thinking or mind of the customer into a kind of a form that can easily be converted to a functions, system view. In terms of implementable view in a computer system. okay, through some programming language. So that is the role of the analyst, and they normally put it in the SRS document. So from there, then it's easier to identify what are the functions that need to be implemented, okay, and then how one function is related with the other functions. What is the input to that particular function, and what is the output from that function. I mean, so these things to be identified, okay, and then if necessary, because initially there are very large functions, and then those large functions need to be solved through more smaller level of we call it sub functions, that also to be identified, okay, and then flow between those different functions and sub functions also to be identified. Say for example, for a library system, let us assume there are few functionalities that will be there in majorly, that searching a new book, then transactions, like issuing a book, then what is called, then updating the library database, okay, and then report generations every frequently. So let us assume these are the major thing that our library wants, okay, searching facilities, okay, then the transactions means issue and return, when you are going to when you go to issue a book, when you are returning a book, and then update, okay, then definitely the different reports generation. Now searching, what type of searching you're going to do, these are the sub functions, okay, it may be book searching, it may be article searching, it may be something else. You can search the whether what is called the forward searching and everything. So searching can be anything. And what type of searching, how the searching will going to be, whether it will through author based, whether it will going to be keyword based, whether it will be subject based. So everything is going to be taken care later on. But broadly, there are say four functions that the library software is going to perform: searching, transaction related activities, updating, updating related database related activities, and the report related activities. So so this and then you have to subdivide these activities. So this is a bigger picture in terms of the different functionalities that the software is going to play. And then again you have to take the help of some other diagram, that what will going to be the input to the different functions, okay, or different functions, and what is the output from the different functions, how one function is, or normally called it as process, okay, we call it as process. So I'll get to refer always the process now, so instead of function. So every the process, how one process is dependent on the other process, okay, so accordingly it will go on. I mean that they plan and they did diagramming, and then once it is done, once it is nicely designed, then it will be easy for the coding team or implementation team to implement every module, okay, every module, by understanding what is the input, what is the output, and what is the functionalities which are there inside that process. So then once they can understand, they can build up that logic for them. Now, this is one of the diagram that is very important. For understanding the different processes which are there. What is the input to that system? What is the output to that system? How one process is connected or dependent with the other process? What values that are going to pass from one process to the other process? Everything diagrammatically can be shown through what is called the data flow diagram. Okay. So data flow diagram, there are two ways that structure analysis can happen. One is called high level design, another is low level design. High level design means very abstract form, avoiding much inner details, micro level details of that different process. So broadly, or from top, how the software look like, that can be done in architectural design. And detailed design is basically low level design, and the low level design is somewhat very close to the programming language. Okay, it's very close to the programming language. It's somewhat like almost you have done the coding kind of thing, like pseudocode. Okay, pseudocode kind of things that are going to be there in low level design, that is directly implementable looking into the detailed design. So architectural design is a very top view, very abstract view. Okay, but low level design is basically which can be looking into that low level design that can be implementable using any programming language. So in high level program design, what happens basically, they subdivided the different tasks in the form of a modules, as I mentioned, and which module to be called by which other modules, that will going to be there in high level architectural design, as I've shown in the programming. One of the high level design is that hierarchical tree, the different modules and their sub modules that it shows in the library example. Okay, and then in the detailed design is how the modules will going to work, what are their inputs, what is their output, okay, which data structure to be used, which algorithms to be used for that module, and everything will be there in the design. Now once a designer they decided ki what data structure will be there and what algorithms to be applied, to implement that particular module, then the next job for the coder is just to simply follow that thing, that's all, nothing else. Okay, so they don't have to think much about that, how we're going to implement. They just need to do what to implement. Okay, so that is the thing that will be there in the detailed design process. Okay, now next phase was is the basically the implementation, that as a fresher it is going to be your task. So what is the task? As I mentioned, once you have a detailed design, okay, once you have a detailed design, software design, then it's now have to code that thing in any particular programming language code. So you have your task is to just what is called source code development. But whenever we do, basically once we develop a small module or small function, what we do, we test every now and then, even in our program also, in during your first year program or whatever program you have written. This is whatever you are doing. Basically, you are doing always rigorously what you are doing. You are developing something and then you are testing with some value whether really it is working or not. Okay, very smaller level you are doing these things or not. So that means implementation of the code and unit testing is actually mixed up with each other. Okay, you hardly we differentiate. We are developing the code and then we are putting some values and we are expecting. We are just waiting for the expected outcome. If it is working as per expectation, so we'll say our coding is perfect. Okay, so that is what we call it as a unit testing. Okay, so coding and unit testing, that comes always goes together. Okay, and that fall under that what we call it as implementation phase. So during what happens during the implementation phase, uh, the models are being coded with the help of some programming language, and every time these models are tested. Okay, tested with some values, what we normally call it as a test cases. Okay, there are the set of values we consider. Say let us assume some modules are there, small modules are there for implementing prime number. So what we'll do basically, that for functions, you know that this is the functions. Now to test, you will give some prime number and give some non-prime number. Okay, and then you wait for the output. So if it is behaving as per the expectation, so you will say that my implementation is okay. But just mind it, just looking into that unit testing doesn't mean your software, there will be no bugs in the overall software. Okay, because it's a very larger picture. Okay, you are dealing with a very small picture, a small module. Okay, and that module may be dependent on some other modules also. So who knows what input is going to come from there. So let us assume you are doing x by y somewhere. So you know this is coming, and so you have written and your program is done. But who knows whether y is going to be zero or not? If there is an y is a zero, then naturally your program will going to be crash. Okay, but if you do not, it may not happen that it. I mean, you can think of all those things at the early stage until unless you do a complete testing of the whole software. Okay, so that means, and then naturally once you are, I mean, implement these things, and it should be the every module should be well documented. Every line, how, what is the role of that every line, what are the variables that you have added, and how we are calling the other, invoking the other functions from there. And that should not be deviate from the actual design. It should always tally or match with the actual design document, the detailed design document. Okay, it should not come vary. If they have done some way and you have done some other way, no, that company will not going to entertain such kind of own style of doing these things. You have to follow the design. Okay, you may say that no, if I do in this way, that will be much better. No, it's never they never entertain such kind of comments from the developers. You have to strictly follow the company's standards, and that the whatever task has been given, you have to follow exactly like that. Okay, exactly like that. You cannot deviate from that, because if you deviate, possibly it would difficult later on to detect any issues in that code, or during maintenance of suitable code. Because normally what they do later on, they look into design, and then look into the code, corresponding code over there. So there must be always a kind of a mapping from design to the code. So if there is mismatch, so it would be very difficult to detect where exactly happened, what you have implemented. It's very difficult. So that's why it must be a very good match between the document and sorry, design document, detailed design, and the code or modules that we have implemented. Okay. So, what is the purpose of unit testing? You are doing every time you are doing unit testing. You're just giving an input, as I mentioned, for a primary prime number and all, and then you are wait for the expectation. Okay. So then the end product of the implementation phase will going to be, you take a set of modules and then test all, I mean, individually, and then I will see another testing that is called integration testing. Okay, integration testing is basically unit testing is basically module by module you are testing, but integration testing means since modules are connected with each other, they are dependent on each other. One module can take the help of other module. So then, as a whole, the integration testing will going to take up all the modules. Okay, all the modules, and then go on adding one module with the other module, and through the what we call it as a integration testing. Say, for example, I mean, there is a one module through which it will going to generate randomly some roll number or some ID. Now, it basically takes in nowadays in the package based system. This is easier. This is also kind of a modular system only. You are taking the help of other module. You are calling some packages, okay, which are available in the library functions and all, without looking into that. So you are basically taking the help of other modules which are readily available. But in some cases, these modules may not be available. So say you have module a function, and that function is taking the help of the output of the module B, another function. So definitely you need to call that function or function B. Okay, the function B. So then what will happen? You are you are calling a function from function A, the function B, and passing some parameter, and then it will going to give you back some output, and then that output you are going to utilize in function A. Now, if the so you are testing function B separately, you are testing function A separately. Now, what integration testing will do? Now you combine function A and function B together. Means you pass that message value from function A, and give it to function B, and then the output of the function B we are going to use it in the function A. So now if there is any error that may happen during passing that value to the from the what is called function A to the function B, so then naturally you can expect an erroneous output again back to the function A. So these things, until unless you are integrating, you are joining all together, you cannot able to understand what's the error over there. Okay. So that is the main role of integrations. You are taking module and joining one after another modules and go on testing these things. Okay. And then what the system testing is doing, system means the hardware and software. So once your system is done, now it is up to the whole systems will going to be deployed in a real system. Okay, in a real system. Say you are putting it into a cloud. Okay, with more number of processors, with more number of memory space and all. So then you will see how, and also the operating system, of course. So that also it have to be taken care during system testing. Say you have developed anything in Linux, so you feel that my software is working fine. Now you have to test it with other operating system also. Okay, because there are high chance that whatever you have developed in Linux environment, that may not work properly in the Linux environment or Mac environment. So these things also be taken care in the system testing phase. There are so many other, what is called, there is so many other kind of testings are which are available. When we'll study in details the testing, then we're going to do these things. Now, another important system testing is that it's not only just hardware and software, but it also the whole software, how it is working, that also have to taken care in case of system testing. What is happening, how will going to happen, that the things which are already documented in the form of an SRS, okay, that this is going to be our input and this is going to be our output. In the system testing, it basically tests whether is it really my system is working as per the SRS document, as per the client's need. Okay, so that is what we actually system testing. If you can remember the one of the image that I have shown in the first class, that clients is looking for a swing kind of thing. Okay, on the tree by using some weight, by using tire, putting a tire and all, tightening a tire and all. Some way, some kind of swing they want. Okay, but architects are unable to do that thing. They think of some other way, and then that may pass it to the implementation team in some other way, and finally they come up with nothing. Okay, so the system testing is basically deals with whatever the system has been developed, whether really it is the requirement of the, or it satisfying the user's requirement or not. Okay, so that system testing is the ultimate testing that matches with the SRS document or whatever it is specified in the SRS document. This is the thing that client want, and whether this is the thing that my overall software is giving or not. Okay. This is up to that. This is the development phase. Now it goes to the maintenance phase. Okay, maintenance phase means, as I mentioned earlier, this is the most longest, most effort-taking things, and till the life of the softwares are there, maintenance is always going to be there. You see MS Word. MS Word still it is developed in long back, okay, and then it is going on different evolution. It's basically maintenance upgradations is going on, okay, and maintenance and upgradation is going on. And Microsoft, so Windows, it's going on different versionings, and all. But ultimately it is in the maintenance now. This is the long term lifelong activities till company thinks we will going to continue with the Microsoft product. It will go on doing this maintenance only. Once they feel no, we're going to stop this product, then there will be no maintenance. So till that means that is the end of that life of that particular software. So till the software is alive, it is in active mode. Uh, what is called, then in that case, you have to continue in the maintenance. Okay. So maintenance of the software product requires, as I mentioned, it's taking much effort. Okay, and if you divide the whole thing, the effort for development phase is 40%, and remaining 60% is for the maintenance. So you can imagine how maintenance is important. And nowadays in India and all, they are doing this maintenance work or the service work. Okay, software service, they are doing the maintenance task. Most of the newly recruited people, they normally deploy in the maintenance kind of phase. Okay, and because they requires much more manpower in maintenance, and clients also have to pay money for that maintenance if it is a client based system. Okay, there are different types of maintenance. We'll also study later on. So what is called the corrective maintenance? As the name suggests, you can easily understand what is the corrective maintenance. Corrective maintenance means during the run of the software, there may be some bugs may occur. So that corrections you will do it into that in your code. Okay. So that is called corrective maintenance. And then if you are trying to make it more effective, okay, in terms of say memory requirement, if some functionalities or some process may taking much time, you may do some corrections so that it can now take better with the memory or processor. Say I'm giving one instance for that. Okay, so that actually helps. Or say user experience, the user interface, it's not very effective. So if you can design a very good, initially you have developed some user interface, and then later on you observe, this interface is not very convenient for the user, so you can go for some kind of perfective maintenance. It's not exactly corrective, it's a perfective. You are making something more perfect. Okay, it's working fine, no bugs, but you are making more perfect. So mainly the UI improvement is basically related to the perfective maintenance. Okay, they are making it more perfect. And then adaptive means, a software you have developed for the desktop, later on then you have decided ki, now our company decided so it should become mobile compatible. Now if you put it over there, so that adaptive maintenance is basically deal with that. Say you are changing the operating system. Okay, operating system. So that should also should work properly, like the way, that means it should be neutral of any operating system. It should be neutral in any platform or these things. Say your UI is something like that, that is very nice, visible in a very large desktop screen, but it is not very good in a small screen, or it may not be good in smartphone or something like that. So you have to think about that, how you can make that system correct, so that it can adapt with different working environment. So we will study more in maintenance later on. Now, whatever we have discussed in the classical waterfall model, as I've also given hint, that they assume that there will be nothing will going to happen, error may happen, error each step, or it should not propagate to the other steps. Say designing, you will assume that design will going to be perfectly okay. So perfectly okay. So in that case, what will happen? That will never going to propagate to the design to the implementation, and implementation to the testing. So they always feel ki there will be nothing to be corrected in the previous step. Okay, in the previous step. So no backtrack. No backtrack is allowed in the classical waterfall model. Okay, they just simply, like in water, going from one step to the other step, uh, like a stream. Water stream, waterfalls. You can say waterfalls, water stream, whatever it is. So, but there will happen that you can detect a kind of an error in the design during implementation itself. Okay, then you have to go back and you have to correct the design. Okay, and during designing, designing, you may encounter something which may be issues in the SRS. So you may have to correct it in the SRS itself. So it can come at any time, and it need to be corrected in the previous stages itself. So that is not allowed in case of waterfall, classical waterfall model. To correct that thing, it has come up with something called iterative waterfall model. Okay, so as I have mentioned, that classical waterfall model is very kind of a very rigid kind of a model. Okay, that they also consider that no defect is introduced during any development activity. Okay, so no bugs will going to be incorporated over there. If it is incorporated, generating, it will going to be confined within that phase only. It should not. There should not be the error. Should, I mean, they always feel that error may occur just because of that phase. But that error may occur not just because of that phase, but it may occur due to the previous error in the previous state. Say implementation, there may be a bug, something happening, logical error or something like this. Syntactical error is fine, logical error. But you'll observe that this is there in the design. You have followed that design and you have done. But that means some error is there in the design, not in your implementation, because you have followed correctly. So that means you have to go back and then you have to done some changes in the design phase itself. So, but classical waterfall model, they feel no defect will going to be introduced during that. Okay, so that means in real life it is very much possible. So the defects or bugs maybe go inside at any phase during that life cycle. So and normally what happen na, these if you go on developing every phase, one after phase, but normally the things have been detected very later stage. Okay, so now so you have completed the whole development and you'll observe the major flaws in one of the design or in the requirement phase. Okay, so that means it's very difficult. So say let us assume you have completed the development or system testing that you are doing. Now while we are expecting, you are observing that you have done everything, you have followed completely one stage to the other stage very properly. But finally when you are matching with the SRS requirement, the requirement, you observe no, it's not matching. It's giving something else. Customers say no, this is not the thing that we have wanted. Then they may identify, okay, fine, there is some error, not error, there is something communication gap which has been documented in the SRS document. Okay, then they have to correct it again, and then you have to redo the design, then you have to redo the implementation, some part, and then you have to go to the testing and everything. So that's why the errors are normally detected at the very later stage in the software development life cycle. Okay? So see, this is the thing, that the same classical waterfall model, now there is a feedback error has been given. From maintenance you can go to the integration. From maintenance you can go to the coding, coding to testing, design to what is called requirement specifications and all. So you can go back. Okay, you can go back to from one phase to the any other phase to correct it, and then again you come back. Okay, once you are correcting a previous a higher level step, then again you have to redo the design. Then say let us assume you have identified during maintenance, you have identified there are some flaws in the initial requirement analysis. So then you have to go back and you have to correct that SRS document and all. And then once you are correcting, naturally you have to again come back to the design, then coding and testing, and then again integration. So so this is the flexibility that iterative waterfall model it gives. Okay, so the box can be introduced at any moment of time, and that need to be corrected in the previous stages also. So errors should be detected in the same phase which are basically introduced. Okay, and say for example, if a design problem is detected in the design phase itself, no problem. Okay, because since the design problem is already detected, or implementation level, it is only confined within that. But the fact is that if it is identified, say in the later phase, okay, say some error in the design identified in the later stage, then definitely it is very time taking. There may be very huge chaos may happen, that because of these small changes there may be very big ripple effect changes may happen during the overall software. So it's very risky. Okay, very risky. So it occurs. It occurs. That's why software company, they don't want to try with very completely new type of thing until unless they have a developed product, they have an experience. They normally don't want to take very challenging kind of thing. If they have an experience, then it is they have a confidence that okay fine, we have designed similar to a product with earlier, so this product we can develop. So that's why they don't want to take much. This is not a kind of a adventure kind of thing. It's a cost which are involved. It's a developers salary involved. It's, I mean, not developers, the whole team's software development team's salary involved. Everything it is there. Now this is another model. Today we're going to start. Today we're going to end up by discussing these things. By the way, am I audible?
Yes, sir. Yes, sir.
Sir,
So this is another thing that I have talked about. Nowadays, this also is a very popular model that is called prototyping model. What is the prototyping model is based on, because see, as I just told you earlier, it's very difficult to understand the customer's mind. What is the customer's need? So now what they do, what company they do, they try to create a kind of a toy software based on the initial understanding of customers requirement. Okay, they develop a kind of a toy software. It's not the full-fledged software, but it's a kind of a workable software where they give it to the customer, okay, to play with that. Okay, some kind of dummy data and everything that they give, some kind of toy, these things. And then once what is called once customer is satisfied, it's fine, or customer may say no, this is not the thing that we want, these things. So then the developers will going to, or the software team will going to, development team will going to incorporate all the things what the based on the customer feedback and all, and then go on, these things will go on, they improving that initial prototype, and this will go on. So by this way, by playing with some kind of tool, it is much easier for the customer to understand what the software will going to be look like finally, and that also easier for the customer to comment on that, to give their own feedback. Okay, so this is basically a kind of a continuous iterative process. Okay, iterative process through which the company can also understand what is the customer requirement, and customer can also understand what the system will going to be look like. Okay, so that's why they give a kind of a prototype for that. Okay, so but of course it's not a full-fledged software, so it will going to have a very limited kind of functionality just to understand what is the customer needs. Okay, and then of course you cannot use it for your actual work, so it's low reliability because it's not meant for actual use. Okay, but inefficient of course performance they have not done. Just to understand how roughly how the software is going to be look like, the prototype model, prototypes can be developed. And one thing is very good is that, I don't know whether it's mentioned or not, good is that they normally, then the once the prototype is developed, they normally, the developers, they normally don't throw that prototype. What they do, they just, since it is already being, they also grown up an idea okay, how the software is going to be both party, then they refine the prototype to make it a full-fledged what is called the software. So what are the reasons for developing a prototype? It helps customer to understand or collecting the input, understand by the customer that what, how they are going to give that input, whether it's a hand typing, whether it's Excel sheet uploading. Say I'm giving an example. What are the messages that will going to show if there is an error or something like that? How the screen will going to look like? UI is also very important in prototype. Okay, how my screen will going to be look like after complete development. That easily that can be done through some prototype toy implementation of that. Without any functionalities, you can think of a design of a UI by putting some different components, no use and all, so that customer can now have a visual impression how the finally the it will going to be look like. Okay, so it basically examines the technical issues associated with the product development by both the parties. Okay, uh, like how basically how I mean the soft hardware is going to be time taking factors also going to be there, or I mean say for example if you put a small dummy data, and if you put a kind of a sorting algorithm to sort the data, then you can easily understand how whether it's really very effective algorithm will going to be or not in different prospects for that data that user is uploading, whether it can be done or not. So lot of things that can be at least get an idea through those prototype development. Okay. Okay, fine. So next class, I'll start from this prototyping. I'll continue with the prototyping model. So if you have any queries, you may ask if you have any doubt and all. Any query? Any queries? Yes or no?
No, no, sir.
Okay, fine. So let us wind up today. Thank you. So I don't know whether I can able to take any more class in this week. If I take, then I'll let you know. Okay?
Okay,
Do you
sir.
understand? Okay. So I'll let you know if I
Okay,
take.
sir.
Okay, thank you. See you.
Thank you, sir.
Yeah.
Thank you, sir.
Thank you, sir.